This is uranium. Uranium is a radioactive element that is used in many different things, particularly in the military field. These things include nuclear power, vehicle armor, aircraft counterweights, and radiation shielding, as well as munitions. A non-military application of uranium is when it is used to date the Earth. This process is called radiometric dating. The element uranium was first discovered by the German chemist Martin Heinrich Klaproth back in 1789. He named uranium after the planet Uranus, which was discovered 8 years prior. He discovered the element while analyzing the mineral pitchblende that came from the Yakimov silver mines in the modern-day Czech Republic. While Klaproth discovered the element, it was the French chemist Eugène Melchior-Pelligot that isolated the pure metal in 1841, and it wasn't until 1896 that Henri Becquerel, a French physicist, that discovered uranium's radioactivity. Uranium has 92 protons and 92 electrons. Its atomic number is 92, with a mass number of 238. The atomic mass number is 238.03. The number of neutrons depends on the isotope. Uranium-238 has 146 neutrons, while uranium-235 has 143 neutrons. Uranium has at least 24 known isotopes. However, only 3 are naturally occurring. Uranium-238, which is the most abundant, making up 99.3% of natural uranium. Uranium-235, which is the second most common, making up 0.7% of natural uranium, and is used in nuclear reactors and weapons. And uranium-234, which only makes up 0.01% of natural uranium. Uranium ions have several positive charges. The most common ones are 3, 4, 5, and 6, depending on the chemical environment. Highly charged uranium ions, like 31 or 35, can be produced in laboratory settings for experiments like particle accelerators. The symbol for uranium is just the letter U, and is classified as an inner transition metal. It is in the period 7 actinide family, and because of this, it has an atomic radius that is larger than elements in preceding periods, as it follows the general trend of increasing atomic radius down a group. Through the actinide contraction causes the radii to decrease across a series. Uranium has generally lower ionization energy and electronegativity compared to p-block elements in the same period, consistent with its metallic character. It is a highly electropositive and reactive material, reacting with almost all nonmetals and their compounds except for noble gases, which is consistent position as a heavy metal. Since all isotopes of uranium are radioactive, all are also unstable by inheritance. Uranium's bonding properties are complex, and I don't really understand them that well, but bonding characteristics include a mix of covalent and ionic bonds. Because its 5F at 60 overlap significantly with ligand orbitals, creating strong covalent character, especially in UN bonds. There's also a remarkably strong covalent bond that has been observed called the uranium-nitrogen triple bond. I'm going to say that the properties are more covalent than ionic, since it seems there are more mentions of covalent. It does have a mix of ionic and covalent, though it seems more covalent. This is the orbital notation for uranium, both the shorthand notation and the full notation. The electron configuration is the same. The only real difference is that the electron configuration is more concise. This is the Bohr model for uranium. Uranium has 6 valence electrons, and being a neutral atom, its charge is 0. The density of pure uranium is approximately 19.1 grams per centimeter cubed. However, temperature and crystal structure can make it vary slightly. Uranium has a melting point of 2070 degrees Fahrenheit, or 1132 degrees Celsius, and a boiling point at 7,468 degrees Fahrenheit, or 4,131 degrees Celsius. I'm not sure of its environmental or biological importance, since it's mostly harmful to the environment and to people, mainly since it targets the kidneys of people, and is very dangerous to ingest and inhale. But it does have industrial importance, as it is fuel for nuclear reactors to generate low-carbon electricity, powers Navy ships, and the decay chain of uranium produces isotopes vital for cancer therapy, medical imaging, and sterilization. Something I found out about uranium is that apparently naturally occurring isotopes were created by astrophysical events like supernovae and neutron star mergers billions of years ago, meaning the element of uranium has existed since the formation of our solar system. And that's it.